Hello and welcome to a probability video on probability trees. Okay, so we're going to look at probability trees today. Now, there are two very key points that I want us all to be aware of as we are doing probability trees, and these are the following. If you say the word "and" in probability, that means you multiply. Okay. And if you say the word "or" in probability, that means you add your probabilities. Okay. Now I want you to hold those in your head throughout this, so that whenever you're doing work on probability, if it asks you to find the probability you get this and this, you know you have to multiply your two probabilities. If it's the probability you get this or this, you add your two probabilities. Okay. Right, so let's just look at this question. There are 7 red, 3 blue and 2 pink pens. I take one at random, I note its colour and I put it back. I then take another. Draw a tree to show this information. Now the question will not always ask you to draw a tree, but you need to get into the habit of drawing a tree so that you can guide your thinking. Okay? So when I go to take a pen, I can either take a red, or I can take a blue, or I can take a pink. So what this probability tree is doing is it's giving all the options of what can happen. I can either take a red or a blue or a pink. So I take a pen. This is the first pen I take. Okay, this is what can happen. I can either take a red or a blue or a pink. I take a pen and then I put it back and then I take another one. So when I then take another one, it doesn't matter what has happened in the first pen, I can still either take a red, blue or pink. So if I've taken a red, I can still take a red, blue or pink. If I've taken a blue, I can still take a red, a blue or a pink. And if I've taken a pink, I can still take a red, blue or pink. Okay, this is the second pen I take. Doesn't matter what I do with this pen, doesn't matter if I keep it or if I put it back, because that's all that we want to know that's happened. So, the probability I take a red pen is going to be, there are 7 red pens, but don't write 7 because it cannot be above 1. 7 out of, how many pens are there in total? Well, there's 7 red, 3 blue and 2 pink. So that makes 12 in total. So there's 7 out of 12 is the probability I take a red. The probability I take a blue is 3 out of 12. And the probability I take a pink is 2 out of 12. Now you can simplify these two probabilities down, but I wouldn't recommend it until the very end. Okay, so when you're doing a tree, don't simplify your probabilities until the very end. Okay. Now because I put the pen back once I've taken it, the probability of taking a red, blue or pink on the second pen doesn't change. Okay, so these probabilities all stay the same because there's still the same number of pens in there because I put the pen back that I took in the first place. Okay, so if I take a red pen, the probability the first time, the probability I take a red pen the second time is exactly the same. Okay, right, then I would like you to get into the habit of writing at the end here what has happened. So the tree diagram gives us our journey, a journey of what has happened. So we're starting here, and this is saying, okay, I take a red, and then I can either take a red, so if I end up here, I've taken 2 reds, a red and a red. If I end up here, that means I've taken a red and then a blue. A red the first time, a blue the second time. If I end here, I've taken a red and a pink. If I end here, I've taken a blue and then a red. Here I have taken a blue and then a blue. I've taken 2 blues. Here I've taken a blue and then the second time I've taken a pink. Okay, hopefully you get the idea with thinking about what has happened each time. And that is our probability tree. Okay. Then question B. So that is your probability tree completed. It has to have all these probabilities on in order to be a full probability tree. It then says, calculate the probability I take 2 pens the same colour. Okay, so if I want to take 2 pens the same colour, I either have to take a red and a red, a blue and a blue, or a pink and a pink. Those are my options, okay? Those are 2 pens the same colour. Okay, let's think about a red and a red first of all. In order to have taken 2 red pens, I need to take a red pen first of all, and then another red pen. So I've got to take a red and a red. So a red and a red is going to be 7/12 times, because it's multiply, it's and 7/12. Okay, don't forget timesing fractions is easy. You times the top, times the bottom. Okay, so that is the probability of taking 2 reds, a red and a red. Then we've got to do the same with the blue. So the probability of taking a blue and a blue is 3/12 times 3/12, a blue and another blue. So that's 9 out of 144. And the probability of taking 2 pinks is going to be 2/12 times 2/12, a pink and a pink. So a pink times by a pink is 4 over 144. Okay? Now you'll notice I haven't simplified any of my fractions yet, and the reason I have not done that is because this step becomes easy. So, the question asked me to find the probability to hit 2 pens the same colour. It doesn't matter what colour they are, but they've got to be the same colour. So that's either 2 reds, or 2 blues, or 2 pinks. Okay, so that's going to be the probability of taking 2 reds, which we've just worked out, or means add, the probability of taking 2 blues, or the probability of taking 2 pinks. And don't forget, when you add fractions, you add your tops and your bottom stays the same. Okay, so 49 add 9 is 58, add 4 is 62 out of 144. Your bottom stays the same. Okay, you can then simplify that. We can halve the top and bottom, 31 over 72. That is the probability of taking 2 pens the same colour. Okay. I'm just going to look at one more example of a basic probability tree, and here it is. The probability I win tennis is 0.65. The probability I win badminton is 0.4. If I play one game of each, find the probability I win at least one game. Okay, so it hasn't asked us to draw a tree here, but we are going to draw a tree anyway. Okay, so when I play tennis, the only 2 things that can happen is either I win or I don't win, i.e. I lose. Okay, so when I play tennis, the only 2 options is that I win or I lose. When I play badminton, I can still either win or lose. And it does not matter if I've won or I've lost tennis, I can still either win or lose in badminton. Okay, the probability I win tennis is 0.65. The probability I win badminton is 0.4, and it doesn't matter if I've won tennis or lost tennis, the probability of winning badminton is 0.4 and 0.4. If the probability I win tennis is 0.65, the probability I lose tennis must be 0.35. That is 1 minus 0.65. If the probability I win badminton is 0.4, the probability I lose badminton must be 0.6. Okay? Now, let's think about what's happened. So if I end here, that means I've won and I've won. I've won both tennis and badminton. If I end here, I won tennis and I lost badminton. If I end here, I lost tennis and I won badminton. And if I end here, I lost both games. Right, now on to the question. If I play one game of each, find the probability I win at least one game. Well, if you're winning at least one game, that's this one, or this one. So we've got to work out each of these probabilities, and then it's either of those, so we have to add them together. So the probability of winning and winning, I'm going to times my probability, 0.65 times 0.4. Okay, and when I times those 2 together, I get 0.26. That's the probability of a win and a win. A win and a lose is going to be 0.65 times 0.6. And when you times those together, you get 0.39. And finally, a lose and a win is 0.35 times 0.4. And when you multiply those 2 together, you should get 0.14. So if I want to win at least one game, I either have to win both, or I have to win tennis and lose badminton, or I have to lose tennis and win badminton. So I'm then going to add those up, and when you add those up, 0.26 and 0.14 is 0.4, so that will be 0.79. Okay? If you want to think about it as doing, it's the probability of these 2 taken away from 1, then that's fine. So the probability of losing both is that times that, and if you do 1 take away that, you should end up with the same answer. Or, which you can't see, 0.79. Okay?